Deep beneath the waves, a brand new U.S. submarine waits in silent darkness, packed with cutting-edge tech designed to change the balance of power. With a single command, it can launch a deadly volley capable of reaching Russian territory in just 32 seconds. Stealthy, swift, and nearly invisible to enemy sensors, this silent underwater giant embodies America's push for unrivaled dominance beneath the sea. Today, we boldly unveil how this marvel of engineering transforms the art of naval warfare forever. Imagine you're deep underwater, the surface world miles above you, and all around is calm. That's exactly how America's newest submarines, the Virginia-class fast attack submarine, USS Iowa, operate, silent, unseen, and packing serious power. The U.S. Navy's underwater fleet is its secret ace, giving the country unmatched reach, deterrence, and strike ability wherever trouble brews. These subs aren't your old diesel boats. They're nuclear-powered, meaning they can stay down for months without needing air or fuel. While other vessels bob up every few days, these submarines slip through the depths, unheard, unseen, and ready for action. That stealth makes them perfect for both watching enemies and delivering fast, precise blows if called upon. According to the Navy's fiscal year 2026 building plan, 6 new battle force ships are on the way. 2 of those are Virginia-class USS Iowa, nuclear-powered fast attack submarines. These subs are the cutting edge of undersea warfare, built for speed, stealth, and heavy firepower. You can picture them as high-tech hunters of the deep, scanning for threats, gathering secret info, and, if needed, striking with missiles and torpedoes. Recently, the Navy handed General Dynamics Electric Boat an $18.5 billion contract to kick off the Virginia Block 6 series. That's a huge deal. It shows just how serious the Navy is about keeping its subs ahead of the curve. Block 6 will feature even better sensors, quieter engines, and a more advanced missile launch setup, all designed to stay one step ahead of any foe lurking beneath the waves. We've already seen these submarines at work. In Operation Midnight Hammer against Iran, a guided missile sub launched a precise strike that put key targets out of action. Moments later, there was no sign the attack had come from beneath the sea. That kind of surprise and speed sends a clear message. Don't mess with an unseen force you can't track or stop. For over 20 years, the Virginia-class has been the backbone of the Navy's attack boat fleet. The story began in the 1990s under the codename Centurion. Back then, naval planners wanted a next-gen submarine that could outmatch anything the old Soviet subs could throw at it. They needed a boat fast, quiet, and packed with smart tech, one that could deter the smartest, toughest enemies. A big part of making that dream real was 3D visualization technology. For the first time ever, engineers could walk through the sub's interior on a computer before a single piece of steel was cut. Every hallway, hatch, and wiring run was laid out virtually, saving time and money on the assembly line. This digital-first approach slashed costs compared to the older, fancier Seawolf class, which had been so expensive that the Navy could only afford 3 boats. Cost matters, especially when budgets get tight. Building a Seawolf could run well over $1 billion apiece. The Virginia class, by contrast, comes in at a much friendlier price. That means more subs in the water, more crews trained, and a stronger, more flexible force ready for anything. With these new Block 6 boats on the horizon, the Navy is doubling down on undersea dominance. Silent, smart, and swift, they give America a clear advantage, and a powerful reminder that beneath the ocean's surface lies a force capable of defending the nation and its allies, anywhere in the world. Budgetary constraints remain an underlying issue. Every mission begins long before the submarine slips below the waves. Thanks to its powerful arsenal, the USS Iowa brings a suite of weapons that turn the depths into a launch pad for precise, far-reaching strikes. At the core of its punch is the Tomahawk land attack missile. Loaded into the vertical launch tubes, these cruise missiles can travel hundreds of miles, weaving through hostile airspace to hit targets with pinpoint accuracy. From hardened bunkers to key bridges or underground command centers, a Tomahawk can deliver its payload without warning, and long before any surface ship can arrive. Below the keel, the submarine carries 4 torpedo tubes that handle a different kind of threat. The Mk-48 heavyweight torpedo is built to hunt both enemy submarines and surface vessels. Once fired, it races through the water at high speed, using a mix of active sonar and clever guidance to home in on its mark. Whether shadowing a hostile sub or closing in on a warship, the Mk-48 brings devastating power in a compact package. When the target is on the surface, the submarine can reach for the Harpoon anti-ship missile. Fired from those same torpedo tubes, the underwater-launched Harpoon pops free of the water before its rocket motor ignites, sending it soaring toward enemy vessels. With radar guidance and a high-explosive warhead, it can disable or sink a ship hundreds of miles away, all while the sub remains hidden below. The vertical launch system itself is a game-changer. 12 tubes sit ready to send Tomahawks skyward at a moment's notice. Because the tubes are built to handle a variety of missile types, the crew can mix and match payloads depending on the mission. A salvo of long-range strikes one day, specialized warheads for electronic jamming, or bunker busting the next. This flexibility means the USS Iowa acts like a floating missile base, able to shift roles with a few quick reloads. Beyond sheer firepower, the Iowa is outfitted for special operations. A built-in lock-in lockout chamber lets combat divers slip out underwater, carry out covert missions, and return without the boat ever surfacing. Whether inserting a team to sabotage a port facility or gathering critical intelligence on enemy defenses, these enhancements make the submarine a stealthy launch point for forces that tread where bigger ships cannot go. Modern naval warfare isn't just about crewed platforms. The Iowa also carries unmanned undersea vehicles that can scout ahead, map the seabed, or even deliver small payloads to distant locations. These robotic partners expand the sub's reach and keep sailors out of harm's way. Send a UUV into shallow coastal waters to survey minefields or inspect a wreck, then recover it inside the hull, all without putting human divers at risk. Every weapon system and specialized feature ties back to the same goal: giving commanders options. Need to soften enemy air defenses before a carrier strike? Launch Tomahawks to clear the skies. Suspect an adversary submarine is trailing your task force? Let loose 48,000 Quacha to flush it out? Hostile patrol boats loitering off a coastline? Harpoons can teach them a quick lesson. Quietly insert a 3-man SEAL team for a midnight raid, then fade away before sunrise. By carrying a mix of long-range missiles, torpedoes, anti-ship rockets, and support for covert teams, the USS Iowa shifts seamlessly from overt firepower to clandestine operations. Behind these capabilities stands a crew trained to run every system flawlessly. Missile technicians school themselves on the latest guidance modules for Tomahawks. Torpedo men maintain the aging Mk-48s and test new firmware to sharpen their targeting. Special Ops liaisons practice lockout drills until every exit and entry becomes second nature. UUV operators learn each vehicle's quirks, how it responds to currents, how to steer it past underwater obstacles, how to bring it home through a narrow hatch. This teamwork turns complex hardware into a cohesive package where every launch, every dive lock, and every data packet matters. In an age where conflicts can flare across continents, a single submarine like the USS Iowa packs more firepower than an entire air wing. Yet it also offers the subtle touch of special ops delivery and robotic scouting. That blend of overt and covert tools makes it one of the most versatile warships ever built. Whether striking high-value targets from miles away or sneaking soldiers ashore under moonless skies, this submarine stands ready to tip the balance of power, wherever and whenever its orders arrive. Picture the massed array on a Virginia-class submarine as a high-tech crown, bristling with the tools it needs to see, hear, and talk to the world above the waves. For the first time ever, the Navy bundled every mast on these boats into one uniform package, the Universal Modular Mast, UMM. Designed by L3KEO, this smart approach means fewer unique parts, simpler upkeep, and quicker upgrades. Imagine building every room in your house with the same set of Lego blocks. This integrated system made its debut on USS Memphis, a Los Angeles-class boat, before rolling out across all Virginia-class subs. The UMM is essentially a rugged, watertight tower that rises through the surface and tucks neatly away when the submarine dives deep again. Inside that tower live all the eyes and ears of the vessel. At its simplest, the snorkel mast lets the sub breathe, While nuclear power makes this less critical than in diesel boats, it still stands ready to supply fresh air or support auxiliary systems if ever needed. Then come the photonic masts, two camera-based periscopes packed with high-resolution color and infrared sensors. They beam real-time, digitally enhanced views straight to the control room, giving a 360-degree panorama day or night without a long tube slicing through the hull, meaning fewer leaks and a crisper picture of the surface world. Communication masts handle the chatter and data links that keep the submarine connected to ships, shore stations, and satellites. By having two separate towers, the boat can juggle multiple frequencies at once, which is crucial during complex missions. On top of that, high data rate SATCOM masts, built by Raytheon, reach skyward for super-fast satellite links. One mast tackles the downlink, the other the uplink, so the crew can download massive files or send detailed reports nearly instantaneously. Think of trading in an old dial-up modem for gigabit fiber, only this one floats. A dedicated radar mast carries the ANBPS-16 surface search and navigation radar, scanning the horizon for ships, icebergs, or any other obstacles lurking above the waves. This radar eye sweeps wide arcs in seconds, feeding clear images back to the bridge. Meanwhile, the electronic warfare mast, fitted with the AN/BLQ-10 system, turns the ocean into an information warfare zone. It eavesdrops on enemy radar pings or radio traffic, analyzes signal strength and direction, and helps the crew decide whether to avoid, counter, or silently slip past potential threats. Because these masts share so many common parts and design choices, the Navy drastically cuts down on spare part headaches and can roll out new capabilities in a flash. Need to upgrade the cameras? Plug in the latest photonic unit without redesigning the entire system. Want better radar performance? Swap in an enhanced ANBPS-16 module and dive right back into service. Now imagine stepping aboard a submarine and finding something familiar in the control room. An Xbox 360 controller tucked beside the sonar screens and navigation charts. Back in 2018, the USS Colorado made headlines not just for its mission, but for being the very first submarine to swap out old-school knobs and wheels for this everyday gaming gadget. It might seem like a quirky upgrade, but there's a clever reason behind it. By using a controller millions of people already know how to handle, the Navy cut down training time and gave sailors an intuitive way to steer the ship's photonic mass. Virginia-class submarines ditched traditional glass tube periscopes in favor of high-tech photonic sensors. Instead of peering through a narrow lens from below the waves, these boats peer through high-resolution cameras, light intensification and infrared sensors, and even an infrared laser rangefinder. All of that data funnels into an electronic support measures array, giving the crew a clear picture of the world above without ever poking a hole in the sub's strong steel pressure hull. Two sets of these photonic eyes, known as ANBVS-1 masts, perch outside the hull like silent sentinels. Under the sea, they stay tucked away, safe from harm. When it's time to look around, they rise smoothly through the water, capturing live images and readings. Streams of optical fiber carry that information down into the control center, where processors translate it into crisp visuals on liquid crystal display screens. Picture sitting at a bank of vivid monitors, swiping and zooming on views of the surface as easily as you would pinch to zoom on a smartphone photo. Before photonic masts, submarines had to slot a thick steel tube through the hull to hold the periscope lenses, which limited how much weight and water pressure the hull could bear. It also meant the control room had to press right up under the sail, the tall fin on top of the sub, so the periscope could drop straight down into it. Now, with no rigid shaft tying them together, designers can tuck the control room deeper into the hull where it's safer and more comfortable. It's like moving from a cramped attic to a spacious open-plan living area. But there's a catch. The new masts look so different from old periscopes that anyone spotting them on the surface can instantly tell that's a Virginia-class sub. In a world where stealth is everything, that's not ideal. To solve this, engineers are rolling out low-profile photonics masts that borrow the familiar cylinder shape of classic periscopes. These sleeker versions hide high-tech sensors inside, blending in with other boats and keeping a Virginia-class vessel's identity under wraps. Looking even further ahead, designers are sketching out a panoramic mast that doesn't even need to spin. Dubbed the affordable modular panoramic photonics mast, this future upgrade would give the sub a full 360-degree view of the sea surface at once, like unfolding a panorama on a smartphone. No mechanical rotation means fewer moving parts to brake, less noise to worry about, and an instant, seamless sweep in all directions. All these changes add up to a submarine that isn't just quieter in the water but smarter too. By using off-the-shelf tech, like an Xbox controller, alongside custom-built sensors and cameras, the Navy stays nimble. Sailors can swap in new hardware or software updates without rewriting whole operating systems, just like installing a fresh app on a tablet. The human side of this story is just as compelling. Sailors who grew up playing video games find themselves at ease in the control room, guiding the sub's eyes with a familiar set of triggers and thumbsticks. That confidence translates into faster reactions when it counts, whether it's spotting a distant ship at dusk or zeroing in on a target with laser precision. In the grand scheme of naval power, it might seem small, swapping a classic periscope for a camera system, trading a wheel for a gaming controller. But each tweak ripples outward, boosting safety, cutting costs, and sharpening the sub's edge. In the unforgiving environment of the deep ocean, being a step, or a millisecond, ahead can mean the difference between success and disaster. And with photonic masts quietly rising above the waves, guided by controllers that gamers around the world would recognize, the Virginia-class boats are charting a course toward the future of undersea stealth and surveillance. Quiet operation under the sea is a major advantage for any submarine, and the Virginia-class boats achieve this with a revolutionary pump jet propulsor developed by BAE Systems. Unlike traditional bladed propellers that chop through water and create noisy bubbles, the pump jet shrouds its rotor in a duct that smooths the flow. Water is drawn in and forced out in a steady, whisper-quiet stream. This design, first proven on Britain's Swiftsure-class subs, dramatically cuts down cavitation, those telltale pops and hisses that give away a submarine's position. By moving almost silently through the depths, a Virginia-class sub can slip past sonar detection and get into position without alerting anyone above or below the waves. Moving on from stealthy propulsion, these submarines depend on top-tier sonar to understand everything around them. At the core lies an open system architecture, OSA for sonar systems. Think of it like a plug-and-play setup. New hardware and software modules can be added with ease, keeping the boat's sensors fresh and powerful. Every 4 years, the Navy slots in new physical components under a technology insertion, bringing in faster processors, sleeker transducers, or more robust cabling. Every 2 years, an advanced processor build updates the software, refining signal analysis and improving target recognition. This steady upgrade cycle means the Virginia-class never falls behind on sensing technology. The main sonar heart sits in a spherical array at the bow. Early boats carried the BQQ-10 system, but starting with SSN 784, a large aperture volley array took its place. This larger, more sensitive sphere can detect quieter or more distant contacts. Along the hull's sides, a wide aperture fiber optic array uses light signals in flat panels to listen for echoes. These panels keep a constant watch on the sub's flanks, feeding clear data to the processing center without adding much weight or drag. Close-in work, navigating shallow water, slipping beneath ice sheets, or hunting down agile targets relies on high-frequency sonars. One sits in a housing under the bow, the other near the top of the sail. Their sharper ping gives high-resolution snapshots of the nearby seafloor, obstacles, or smaller vessels. For over-the-shoulder coverage, a low-cost conformal array, LCCA, wraps around each side of the sail. That array picks up sounds from above and behind the submarine, giving a full picture of activity all around. When stealth demands even greater reach, the boat tows sonar arrays behind it. A fat-line tactical towed array, known as TB-16 or TB-34, depending on the model, trails far back to detect faint noises over medium ranges. For really long-distance listening, a thinner, more delicate line, TB-29 or TB-33, extends even farther, sniffing out submarines or ships miles away. By towing these sensors, the sub ensures it can monitor activity below and beyond its own hull noise, making it far less vulnerable to surprise encounters. All these sonar systems feed into the control center through optical fiber lines and signal processors. The data appears on high-resolution screens where trained sonar operators interpret echo patterns, track contacts, and guide the sub's movements. Thanks to OSA, if a new kind of sensor becomes available, say, one that picks up ultra-low-frequency sounds or processes data faster, the crew can integrate it without ripping out the entire system. That modular approach saves both time and money, and it means mission readiness stays high. Together, pump jet propulsion and advanced sonar make the Virginia-class submarines far more capable than their predecessors. They slip through the water in near silence and keep a 360-degree electronic eye on everything around them, from distant threats to hidden shoals of fish. Whether operating in the icy Arctic, crowded littoral zones, or deep ocean trenches, these boats maintain the edge in undersea detection and stealth. That combination of quiet movement and state-of-the-art sensors spells a decisive advantage. The ability to watch without being seen, to listen without revealing location, and to strike or evade with confidence. By constantly evolving through regular hardware and software upgrades, these submarines adapt to changing threats and new technologies. They stand ready to face whatever challenges the deep sea and potential adversaries might throw at them. In modern naval warfare, maintaining that edge under the waves can prove far more important than sheer firepower. Virginia-class submarines have steadily evolved from straightforward attack boats into versatile undersea platforms, thanks in large part to clever tweaks in their missile launch systems. Early models relied on a dozen vertical tubes, each dedicated to firing a single Tomahawk cruise missile. That setup got the job done, but left little room for flexibility when new mission needs arose. Block 3 changed that by swapping those 12 single-purpose tubes for just 2 multi-purpose Virginia payload tubes VPTs. Each VPT can hold multiple missiles or other payloads, so crews no longer have to commit all their launchers to a single weapon type. In effect, the submarine becomes a Swiss Army knife of undersea warfare, ready to switch from long-range strikes to unmanned vehicle deployments at a moment's notice. Building on that concept, Block V boats introduce an even bigger game-changer, the Virginia Payload Module, VPM. Starting with submarines laid down from 2019 onward, a new 70-foot section appears mid-body between the operations compartment and the propulsion plant. This extra chunk of hull carries 4 more payload tubes, each taller than the original VPTs, and each capable of fitting up to 7 Tomahawk missiles. That brings the total cruise missile capacity up dramatically, replacing firepower once provided by converted Ohio-class SSGNs that are now heading for retirement. By tucking these tubes on the centerline, designers keep the boat balanced and avoid messing with its stealthy shape, while giving commanders more options for missile strikes without needing support ships nearby. Early plans called for 8 new tubes, but engineers soon realized that 4 would strike a better balance between added punch and manageable size. The VPM still adds length and cost. Initial estimates peg the price tag at $500 million extra per sub. Yet by packing more missiles into each hull, the Navy can meet its strike requirements with fewer boats overall, trimming the force by about 4 submarines. Later cost reviews slimmed the VPM budget to around $360 to $380 million by narrowing its mission to Tomahawk cruise missiles and leaving out more exotic cargo like medium-range ballistic missiles. Some of that savings also comes from sharing silo designs with future Ohio-class replacements, taking advantage of common parts and construction methods. Behind the scenes, General Dynamics Electric Boat handled the initial VPM design work, sketching out how to splice the extra module into the submarine's backbone. Final manufacturing is split among BWX Technologies and BAE Systems, who turn the blueprints into real steel and electronics. Contracts flowed steadily. A $19 million award in mid-2016 kickstarted VPM development, followed by a $126 million package in early 2017 to cover lead-time construction costs for the first Block V hulls. Those early investments paved the way for a production line that can weave the extra sections into submarines without drawing out the schedule. Beyond missiles, VPM tubes can double as launch points for unmanned undersea vehicles, a capability Block 3 subs only dreamed of. UUVs can slip out through the same tubes that once held Tomahawks, scouting shallow coastal waters, mapping the seabed for mines, or carrying specialized sensors into denied zones. That robotic edge makes each submarine a mini fleet of its own, combining human crews and machine helpers in a single hull. When a mission calls for stealthy reconnaissance rather than a heavy strike, divers simply swap out the missile canisters for UUV launchers, reconfiguring the boat's role in port in a matter of hours. This modular mindset carries forward into future upgrades. The Navy and industry partners are already sketching concepts for non-rotational panoramic masts and next-gen sonar arrays. By the time Block V boats hit the water en masse, they'll carry more firepower, more sensors, and more flexibility than any U.S. sub before them. Each added tube, each software tweak in their fire control system, keeps them one step ahead of adversaries racing to counter American undersea might. In today's shifting strategic landscape, where potential flashpoints range from Arctic ice flows to crowded Asian littorals, having a submarine that can switch from deep strike platform to covert intelligence gatherer is invaluable. The Block 3 and 5 evolutions prove that even the most secretive warship benefits from a dash of modular thinking. By turning vertical launch tubes into multi-role assets, the Virginia-class remains not just a silent hunter, but a flexible tool of national power, ready to meet whatever challenge lies ahead under the waves.